Hi, I'm JD, and what we're going to be doing today is odd and even functions. What I have on the board is an odd function, even function. First, determine which one is which, and then I'll discuss the reasons why. All right, so if you would pause the video. All right. Determining an odd or an even function is very straightforward. If you look at this, it's symmetrical about the y-axis. It's a reflection on both sides. Since it's y-axis symmetry, this would be an even function. Now, to determine that, if I was to select this point here, and that point there. And notice that this might not be an exact parabola. This is a negative x and it has the same y. This is the positive x and it has the same y. So if this was x squared minus 2, then I plug in negative x, the negative x, right? That's squared, that's going to make it a positive, so that's x squared minus 2. Notice that f of x is the same as f of negative x. And that tells you, algebraically, it's an even function. Here, slightly different. And yes, this is an odd function. Now it's odd because the symmetry is about the origin. If I was to look at, let's do the same thing over here. Take a line, and it's going to go straight through the origin. And I select a point here. This is x positive y. Now this is negative x, negative y. You see that? If I was to select a point here, let's say like 1, 1, this would be negative 1, negative 1. You see that? So this is an odd function. Now determine whether it's an odd function. This graph right here is x cubed. So if I were, so I have f of x equals x cubed. If I would plug in a negative x into this, I get f of negative x equals negative x cubed. Now, if it's an odd exponent, it retains its sign, so it's a negative x cubed. Notice that f here, that f of negative x equals negative f of x. That's algebraically speaking, that's how you can prove it's an odd function. So, let me give you an overview. Determine whether it's an odd or even function. First, you can see visually, okay, what's the symmetry? Is it y-axis symmetry? Okay, that would be an even function. Or is it origin symmetry? Meaning that you can take this and literally reflect it about the origin. If that's the case, then it's odd. That's how you do it graphically. Now, algebraically, either which way you want to plug in a negative x into the function. Once you simplify it, if it turns out to be exact same, this start off as x squared minus 2 and it end up as x squared minus 2, that means it's an even function. But if it turns out that, okay, I can factor out negative 1 and get the original. So it'd be like negative 1 times whatever the function is. That means it's odd. So that's how you determine whether it's an odd or even function.